Unit 4.3.1 is about data collection and the general structure of a research project. The first research method that you may want to use is a case study. This is an in-depth and detailed investigation into an individual, group or team. This investigation usually collects the data by the use of interviews and observations of the individuals or teams. So it's just an in-depth investigation into a person or team's life, about their diet and their training, etc. This investigation is most often in real-life context and is over a long period of time. An example would be collecting anthropometric measurements of young female gymnasts over a period of 10 weeks. This is because you're collecting detailed and in-depth body measurements over a long period of time. An advantage would be that you obtain rich and realistic data because you're purely observing their life and you're not affecting them in any way. The results can be used to improve lifestyles because people in the general public may see this data and copy them so they can improve their general health. And it also gives an unbiased introduction to the case study because again it's purely observational. A disadvantage is that it could take a long time to collect all the data because it's over a long period of time and it's very detailed. And the data can't always be applied to the general public because these are gymnasts and athletes that we're talking about and investigating. The next research method that you may want to use is a cross-sectional. This is another observational design and uses a wide range and variety of individuals. These individuals can be from different age groups, nationalities, genders or backgrounds. The researcher collects data from a cross-section of a population at one point in time. This is called a snapshot. So an example could be collecting data of percentage body fat in 10, 11, 12 and 13-year-old female gymnasts. This is because you've got a wide variety of ages there and you're collecting the data for all of them at that one point in time. An advantage would be that it's not costly to perform because you're only doing it once at that point in time, and again it does not require a lot of time as you're doing it then and there at one point in time. Disadvantage is that it does not help to determine cause and effect because you're not looking at why this is happening, you're only seeing what is happening. A snapshot may not be representative as it may be a small sample size and it doesn't represent the whole age group, and it can't be used to analyse behaviour over a period of time as again it's only a snapshot at one point in time. The next research method that you may want to use is longitudinal. This is also an observational research method in which data is gathered for the same individual or individuals repeatedly over a long period of time. This allows researchers to study long-term effects in the human population. So an example would be gathering percentage body fat of a young female gymnast annually over 5 years and record any changes. This is because it's over a long period of time, so 5 years, and you're annually recording their percentage body fat, so you're repeatedly getting results. Advantage for this is that it can be helpful in determining patterns as it's over a long period of time. This also allows you to get better and more concise results, and you can learn more about cause and effect relationships as it's over a long period of time and you can start to see why it's happening. The disadvantage is time, which is a massive issue in this one because it's over many years and can be decades sometimes. Individuals may get bored or frustrated and may not want to continue, and large sample sizes are required. The next research method that you may want to use is comparative. This is the act of comparing two or more things with a view to discovering something about one or all of the things being compared. So you're getting two or more sets of data, and then comparing those sets of data. An example would be measuring and comparing the height of vertical jump tests of female gymnasts at age 12 and 14. So here you have two sets of data, those age 12 and those age 14, and you're comparing the results of the vertical jump test of those two sets of data. An advantage is that it doesn't take much time because you're only doing it once, right there and then. Also it's relatively cheap, and you can compare their results to normative data. However, disadvantages is that you would need a generalization of data in order to compare, because if you're only doing it for a few of them, then you can't say that will be exactly the same for the whole age group. And if you compare it to normative data, it could be biased because you don't know exactly how they've got their data and how their research has been conducted. The next research method is correlation. This is where the researcher examines a relationship between two or more non-manipulated variables. So again, it's observational. There are also three possible results of a correlational study: a positive correlation, negative correlation, and no correlation. They are always represented in a scatter graph, as a position of the graph can determine what the correlation results show. So as you can see here on the left, you have multiple examples of different correlations, and the correlation coefficient, which is the R value that you can see above the graphs, is a measure of correlation strength and can range from -1 to +1. An example would be seeing if the more times a gymnast goes training a week improves their performance on the floor. An advantage would be they're not in a lab, so the results are true, so they're in their natural environment. It can be conducted on variables that can be measured and not manipulated, so it's purely observational again. Disadvantage is that it only uncovers a relationship and cannot provide a conclusive reason for why. And it doesn't reveal which variable influences the other, because you're not controlling any variables, you're just watching and being observational. The last research method is experimental. This one is not observational, and this is a procedure carried out to support or validate a hypothesis. They provide an insight into cause and effect by demonstrating what outcome occurs when a particular factor is manipulated. The researcher also controls all other variables than the one they are manipulating. There's also a control group, which is used as a baseline to compare groups and assess the effect of the intervention. So an example would be experimenting to see if substance A increases the flexibility of young female gymnasts' hamstrings. So substance A here would be the independent variable, and you're seeing if that has an effect on the dependent variable, which is the flexibility of the hamstrings. Advantage of this is that it's easy to determine the cause and effect relationship, because you're looking at Y here, and you're controlling all other variables, and you get better results due to these strict conditions. Disadvantage is that it can create artificial situations, because you may get the gymnast to come over to a lab, which is not their natural environment. It can be expensive because you have to hire all the lab equipment, etc. And it can be subject to human error because the researcher is the one controlling all the variables, and if they get something slightly wrong, then you can't be certain of the cause and effect relationship. Primary data. So this is collecting data yourself by conducting your own studies. So just carrying out your own research study, gathering results all by yourself. An advantage is that it's direct because it's you carrying it out. You know how it's been carried out. It's tailored to your current research because you're trying to figure something out, like something particular, and it's reliable because you're the one carrying it out and you know exactly how it's been carried out. Disadvantage, however, is that there's a risk of bias because you may want a particular result to happen and you may manipulate some variables to make sure that result happens. Time and money is also a disadvantage because you're going to have to spend time and money preparing and carrying out this research. Secondary data, on the other hand, is data that is acquired from a secondary source. This is where a different researcher has carried out the study and you use their data. So advantage is that there's rapidly available, so you can go on the internet, go on Google Scholar and look up any research project that a different researcher carried out. It's inexpensive because you're not paying any money to look at these, and it provides an insight and support to any theories that you have about this particular study. Disadvantage, however, is that some may provide you with insufficient detail or just the completely irrelevant detail that you don't need, and some vary in quality, so some might be really bad, but some might be a little bit good as well. Quantitative data is numerical data and is data that can be transformed into usable statistics. It uses measurable data to formulate facts and uncover patterns in research. So it can be represented in graphs or tables, and it can be used to uncover patterns. These methods include surveys, face-to-face interviews, interviews over the phone, or systematic observations. Qualitative research, on the other hand, is primarily exploratory research and is used to gain an understanding of underlying reasons, opinions, and motivations. So it's just purely word-based. It could be either verbally spoken or it can be written down. It's also used to uncover trends in thoughts and opinions and dive deeper into the problem. These methods vary using unstructured or semi-structured techniques. So unstructured is you go in there completely blind and you just try and get a conversation. And semi-structured is you have questions, but you rarely base your whole interview off of them. So some methods include focus groups, which is a group interview, individual interviews, and participation/observations. First classification of data is nominal data. This is the least informative classification of data, and this is where data is placed into different categories and are mutually exclusive. Categories can have a numerical value such as 1 or 2, but these have no mathematical meaning. So an example would be finding out people's preferred sports that they play and placing them into different categories. The next one is discrete data. This is data that can only be categorized into certain values, usually 2 categories. Discrete data is data that cannot be measured, such as weight or height, and this data can be numerical or categorical. So an example would be asking if you are male or female, as there's only 2 categories there, or left or right-handed, again 2 categories. Ordinal data, this is data that is organized into an ordered sequence and is more informative than the last 2. The allocated numbers do have a meaning, but the difference or distance between these numbers and categories is unknown. So an example would be in a gymnastics competition, the final positions, so from 1st to 10th, these numbers have a meaning. So first obviously means first, 10th is last, but the difference between those is unknown. Interval data, this is the next most informative and is a numerical scale with a meaningful order, and the distance between the intervals are all equal. So this can be represented in a graph, for example. This type of data has no meaningful zero, as the data can be both positive and negative in value. So an example would be measuring the temperature of a gymnast after their performance on the floor. This is because temperature, although after performance it may not be likely to drop below 0, temperature can still drop below 0. The last classification of data is ratio data. This is the most informative classification and is similar to interval, where the data is placed on a numerical scale with equal interviews and a meaningful order. The difference, however, is that the data does have a meaningful 0, which means that the data cannot be negative in value, it can only be positive. So an example would be recording the heart rate after a VO2 max test, because heart rate can never drop below 0.